And here's the bottom line. The biggest challenge or the biggest metric for these always-on sensing devices is always-on power. And that's the power that's required to actually know what's going on, do applied AI, applied machine learning 100% of the time at the lowest power level, right? And that's exactly what we're striving for, and we're delivering today, and we'll see a lot more of that. I mean, the world is wide open from that perspective because we are so inefficient in how we do things today.
Welcome to the Conversations on Applied AI podcast, where Justin Grammons and the team at Emerging Technologies North talk with experts in the fields of artificial intelligence and deep learning. In each episode, we cut through the hype and dive into how these technologies are being applied to real-world problems today. We hope that you find this episode educational and applicable to your industry, and connect with us to learn more about our organization at AppliedAI.mn. Enjoy.
Welcome, everyone, to the Conversations on Applied AI podcast. Today, we're talking with Tom Doyle. Tom is a veteran in the semiconductor industry, working in many different areas over the last 35 years, including RF and satellites, analog and mixed signal integrated circuit solutions, IP, software, and sales. He holds a BS in electrical engineering from West Virginia University and an MBA from California State University. Tom is the CEO of Aspinity. Aspinity is a world leader in the design and development of analog machine learning chips that are revolutionizing the architecture of always-on sensing devices that run on battery. Aspinity is the second startup Tom has founded and is the first focused on a semiconductor chip. Thank you, Tom, for being on the program today.
Thank you. Thank you for having me. It's great to be here.
Awesome. Well, I said in the intro kind of a little bit about where you are today. Maybe you could tell us a little bit about how you got started in the industry, and then kind of how you came into working with semiconductors and the work you're doing today at Aspinity.
Yeah, for sure. I think you mentioned 35 years, so we have a lot to talk about, but I'll keep it pretty quick. You know, it's an interesting time. I've seen a lot happen over those 35 years in the industry, right? Always been in deep tech, usually in California. It's funny you mentioned it. I mean, early on, I was in the defense industry. That's where I got some of my RF and early processing skills, if you will. And that was pretty much early in the, infancy of really rolling out, what we like to call, really, impressive compute environments. And so from there, learning about that and applying it, I moved into the semiconductor industry and worked there probably about for the last 20 years, let's say 15 to 20 years in Silicon Valley out in California, mostly working around analog, right? Focused on analog, analog and RF capabilities. And then, within probably the last few years, maybe 5, 6, 7 years, I got involved with my university where I'm an alumni at West Virginia University, and met up with two of my co-founders, really, really smart guys, Dr. David Graham and Dr. Brandon Rumberg. Kind of a perfect timing. They were looking at really, really efficient, today we call it edge, but looking at wireless node sensing type applications. And I think we pushed that with regards to understanding what's going on in the industry. I mean, I had that background in seeing a lot of what was going on in technology. And so that's really how we got involved. And we, over the last 5, 6, 7 years, we've been taking this concept and this technology, moving it into commercialization for the sheer purpose of really addressing some of the big challenges in the industry. And that big challenge actually is really all about sustainability. How do we deal with all of these products coming to market, all of what we like to call edge products, right? But everybody else just calls them products, right? It's your phone, it's your earpods, it's everything that you have, right? And in your home, on your body, in the factory, all of these sensors, right? All of these things, these devices that are collecting data. How do we deal with the sheer numbers of information they're generating, and actually the energy to be able to actually use those at our disposal very efficiently? And so it's been actually a very good, very interesting 35 years, moving from defense systems, radars, and satellites, all the way now I'm down into the smallest of technologies that are going to be operating mobily and at the edge, right? So it's very fascinating. I love this stuff.
That's awesome. I would assume maybe cost is one of the biggest changes that you've seen over time.
There's a scale, right? So cost versus performance, right? Versus size, capability. Absolutely. Right. That's been huge. I mean, cost is very impressive, right? And that comes with, with some of the things that we've seen in the industry, but it's surely the amount of capability that we can put into the smallest form factor imaginable, right? So you can look at it couple different ways, and that will drive cost efficiencies. The mobile phone is a magic thing to me, right? Knowing where we were 35 years ago and what we've been able to, make happen. And it's continuing to get better, right? We continue to improve. And so it's quite impressive from that perspective. But yes, cost is a huge driver, but performance is just unparalleled.
Yeah. I just had somebody on the program that I just interviewed yesterday, actually, that is an author of a book on TinyML. It's called the TinyML Cookbook. And as you know, TinyML has kind of become this, I don't know, this phrase that people are sort of bantering around. It seems to flow very much into what you guys do. And that's really, machine learning at the edge. And people are talking about these new chips that are coming out and stuff in embedded edge devices. You guys are focused on, I guess you use this term analog ML. If you take a look at your site. What's the difference in your mind?
Let's definitely talk about that. I think TinyML is a very good descriptor of what we're all focused on, right? So tiny is an interesting word. It implies low cost, it implies small size, and it implies efficient, right? So it's, we're part of the TinyML consortium as well, and have been there for a while because, as you noted, we fit within that domain, and it is focused on, the most efficient edge type computing that you can offer. Now, how do we separate ourselves? How are we a little bit different, right? So we are into the analog aspects of that, right? And there's some good reasons for that, and so we do talk about analog machine learning, which means, yes, we are implementing machine learning models, applied AI models that operate on fully analog circuitry and a fully analog chip. And so I think that's kind of unparalleled in the industry, very challenging on a few different fronts, but the value is tremendous. And here's the reason. When you think about all of these edge sensing systems, they're collecting data for us to have at our disposal. That data, that physical world that we want to look at, say it's biomedical signals, say it's audio in the home, say it's a machine that's vibrating that might be going bad. All of this information is natively analog, right? So we take it, we convert it, and then we do too much with it before we know what's there or not. And so what we're able to do is actually take that information in its rawest form in analog and actually run machine learning models on it to make determinations as to whether an event happened, right? Did somebody break my window? Did somebody say a word? Is that machine starting to go bad? I want to know that as soon as it happens. And by the way, I don't want to keep checking because that's wasteful, right? So I want to be able to be notified when I have something relevant, but do not bother me. And I think the way to think about that too is most digital applications are going to digitize and process a lot of information just to make sure that nothing has happened, right? Now they will catch it when it does happen, but think about all the times that you are applying machine learning models to data when there's nothing there. So think about, I'm going to use a digital processing paradigm to look for somebody breaking my glass. You're taking 100% of the sound, 100% of the time, you're digitizing that. You're looking at it with an essentially a higher power processor, only to find out that nobody broke the glass, right? So it's a different way of thinking. We can let that downstream component know when we have a good indication there was a glass break, and we can do it at almost near zero power by using analog machine learning capabilities.
Interesting. Yeah. And so that's obviously huge power savings, not having to convert it to a digital signal and have to use a different type of architecture or processing power. Yeah. Now, of course, analog can be all over the map, right? There's all sorts of analog signals that could be, false positives, I guess. There's just a lot of variability. I'm assuming you guys have a lot of intellectual property around that, but maybe you can talk about how you maybe address that concern.
It's a really good question. I mean, I think a couple of things to note beforehand, right? So in the world we live in today, there is a need to find more efficiency. Everybody knows what I just talked about. And so, there's also the knowledge that analog can be, a much better means to achieve efficiency, right? If we can use it effectively, right? And that's what we're talking about. Everybody knows I would rather not have to digitize my data. I would rather look at analog data. I would rather do things within the analog domain. In many cases, more accurate, more, better performance for the power as well. But as you said, there are some challenges, and these are well known, and we understand them very explicitly, right? So all of our backgrounds are actually within analog, analog design, RF design, analog circuit technology, non-linear analog processing, right? We have good background there with our team. And so we've been able to approach the actual situation with knowledge and with the ideas and underpinning IP to be able to solve it. And just to make it easy, right, to kind of understand, the one biggest thing that everybody deals with is, oh, I'm going to build an analog circuit because of variability, because of temperature, because of voltage offsets, because of these difficulties. My inputs over a long signal chain versus my outputs are not consistent. And with regards to what we do, so we approach that knowing that we design technology where we're able to take that circuit that's applied for a glass break detector, applied for voice or words, applied for vibrational information, and using software techniques and some of our underlying technology, mostly in the form of our own analog memory, we're able to do a few different things to make sure that that input and the output match across millions of chips. And we use that, our analog memory to be able to store values from which, when we load an algorithm or load a technology, a software algorithm or machine learning model onto our core, we're able to make the adjustments. So we can make adjustments for parameterizing the circuits. We can make adjustments or store values such as weights for our analog neural network. But we can also make precision adjustments that allow us to deal with the variability. And I think that's key to our technology. We can't do that in very many environments without, I think, some of the core technology we have, and namely our own analog memory capability.
Gotcha. And if we focus on like vibration monitoring, like specifically, you guys have your own chipset, I guess, right? You guys have your own hardware.
Yes.
And then you have your own software, I guess, right? That runs on this. Do you generate the models? The companies, like maybe like let's just say I am a company that needs vibration monitoring, right? I have a pump that is running inside a factory. It costs me a lot of money if it ever goes down. How do you engage with customers like that? And we'll obviously put links off to your website and all this sort of stuff in the liner notes of this, but
yes,
maybe I could get a little bit more details with regards to sort of how you engage with your customers.
Yeah, I think you hit on some of it. It's actually a great question. So, I mean, first of all, we provide a proprietary silicon solution, so our own chip, right? We call it the AML 100, and it is, as I described, right, a full analog chip with all the accoutrements of, perhaps like an MCU or another processor that has a SPI interface for interfacing, has inputs, outputs, all the things necessary to integrate it into a system and add value. And now, on top of that, we have a solution stack. So we have an algorithm. So maybe you want an algorithm for glass break, for voice, for vibration. That can be loaded onto our chip, and it's compiled onto the chip. And then we have firmware that integrates it into a larger system, right? So such as an MCU, a DSP, or something like that. Typically, in the short term, we're building some of those models, right? So we build our own glass break model, and we sell that as a solution set. In other cases, for vibration, it's very interesting. So vibration's a little bit of a different animal because all machines are different. So we can build a glass break model and that'll detect glass break. And we're very good at all different kinds of glass breaks because it's a pretty standard signature. It has its challenges, but it's pretty standard. In vibration, typically what people are looking for, like for instance, on a motor, as you mentioned, they may be looking at different indicators. Could be a bearing going bad. It could be a race going bad. It could be a shaft that's off balance. Those actual three indicators would send, let's say, magnitude changes or some kind of change at a frequency level. Like bearings have a very specific fault frequency, for instance, and you have tons of different bearings, right? And what they do today is they take 3-axis accelerometer data on that machine, they digitize it, which is very expensive, right? Minimally 14-bit resolution. They'll essentially then go to a DSP and run an FFT to look at the full spectrum, only to find out what they have or don't have, right? And in the case of what we do, we try to avoid that, right? We try to do things earlier in analog before you waste a lot of that energy looking for a needle in a haystack. And we'll provide, similar indicators to say, hey, in that frequency band, we're detecting some changes that would probably indicate something is starting to go bad. So it's about noticing the change or noticing a certain level of change in energy or in a spike. That may happen in a month, a year, 5 years. We'll be on all the time. We'll be ready to recognize that. And then we'll wake up the system and then run an FFT or then send out a maintenance worker or then do something. So it's a much different paradigm. And the other part of it is too, is we want to be able to allow these end customers to be able to set the parameters from which to look, right? So you don't want to look across the whole spectrum. They know when they put a machine in service that it's going to most likely fail within a couple of different frequency windows. So let's just trap those instead of looking to do a full FFT every hour, right? It's just a patently wasteful way of doing the preventative maintenance on machines.
Yeah, absolutely. It sounds to me like, I guess correct me if I'm wrong, but you're dealing with organizations that maybe have what I would call a dumb motor, I guess, and you're applying your technology and some maybe off the shelf sensor, or maybe the sensor's already integrated to essentially make their motor smart. What does the future look like for analog ML or your company, or even just, I guess, these predictive maintenance solutions? Are we going to come to a world in the next 3 to 5 years, I guess, that maybe already have this technology like already built in? Like I buy the motor and it's already got all this stuff in it. Is that where you guys are sort of headed? Is that where you think the industry is going to go?
Absolutely, right. So today we're dealing with adding technology onto motors, but there's already indicators of companies that are embedding this in because it's such a critical factor, right? Look, whether it's on a machine or in your home or at work, you need to know when things of critical nature are happening, right? And that's exactly the case. In order to do that, today's paradigm makes you do it in a way that you just have to always spend a lot of energy doing it. And that's what we're changing. And so, by the way, with energy becomes size and cost, right? When you save energy to the levels that we're saving it, and again, we're talking, microamps of power to be always on and detecting, you'll find that now you're able to shrink the battery size, which is one of the bigger cost items and one of the bigger size items as well in most of these deployments. And so now you become very much small enough to be embedded, right? Not only embedded one on a motor, but embed at different points on the motor so that you actually know what's going on and you can be very much from a predictive maintenance, not worry about that motor all the time and be comfortable that you're going to be notified when there's something of interest that's happening. And you can apply that to so many products in the world, consumer, industrial, biomedical. It's really a game-changing approach to how we see things, how we see this always on sensing happening, right? And here's the bottom line. The biggest challenge or the biggest metric for these always on sensing devices is always on power, right? So, and that's the power that's required to actually know what's going on, do applied AI, applied machine learning 100% of the time at the lowest power level, right? And that's exactly what we're striving for. And we're delivering today, and we'll see a lot more of that. I mean, the world is wide open from that perspective because we are so inefficient in how we do things today.
And I guess maybe the final piece of that is the connectivity out to alert somebody about this. And that's not what you guys do, right? I mean, you guys essentially alert that something happened, but somewhere there's a wireless radio somewhere or something like that, right? That actually does the notification out. This has gone past the thresholds that we set.
That's correct. And you're absolutely right. So everything is, let's have a staged, highly efficient process for, how we do this always on sensing, right? The first thing is I want to look at all the data. I want to determine if I have anything relevant. If I think I have something relevant, let's make up the next stage, which is typically in our world is the digital stage. Let's look at it locally again to run some different looks, maybe the FFT, as I mentioned, and then let's send stuff out. But if you recognize what's happening, I mean, one of the biggest drivers in the industry is, 5G. That's going to open up the door for proliferation in a very big way, right? So, we're somewhat limited in our communications and, sending stuff locally to a gateway and up to the cloud. 5G is going to open the door and provide gas, if you will, to proliferation of just tremendous amounts of these edge products that are always sensing and always collecting data and giving it directly to you, right? So the thing you don't want is I don't want to know when a leaf blows at my home in another state because my alarm went on. I don't want to know if you think you might have a glass break. I want to know precise data. And I want it direct to me. I don't want it stored in the cloud somewhere. And so it's going to be a pretty interesting next 2 decades, right? With the proliferation of 5G and the movement of all these battery operated, always on systems that we're going to enable as well. So it'll be very interesting.
Yeah, for sure. Cool. Well, one of the questions I like to ask people is sort of like, what's a day in the life of somebody in your position? CEO of a company, you guys are doing some cool stuff. What's your days typically filled with?
Yeah, it's interesting. I mean, in my position, right? So I'm a technology guy. My background is in engineering, but I tend to find myself looking at other things too much and not getting enough time to spend on technology. But technology is our lifeblood. And so, I do, when I'm in the office here in Pittsburgh, where almost all of our team is here, from a headquarters perspective, I get involved in some of the day-to-day looking at new technologies. How are we progressing with different aspects of our solutions? Hey, are we able to do something in this analog core that no one's been able to do and make it repeatable? There's those aspects, and I love those. And the other aspect is just growing the company. I spend a lot of time looking at financials, right? Always
Yeah.
raising money, working with customers as well, to kind of understand how do we bring value? How do we get return on investment to them? And those conversations are great. But it's good to be in this position to be able to delve into the technology and then go back to the financing and the customer side as well.
Yeah, good. Yeah, I was looking at your site. Looks like you guys are actively hiring in a number of different places. I'll be sure and put some links off to your careers page. But looks like you guys are based in Pittsburgh, and you're looking for a lot of talent in that area. Or can people be located wherever? How do you guys work typically?
I think we've more than doubled our staff during the pandemic, right? Which is great. Always looking for the most talented people. Pittsburgh is great. Pittsburgh's been pretty much a transformative city in the sense of moving from steel and those types of jobs to high tech. And so we're able to find very talented, experienced folks from the local universities, Pitt, CMU, and others. But we're always looking, right? So looking in Silicon Valley, looking in all the, throughout the US. I mean, we're always looking for the great talent. And it's a pretty unique job, right? So we can offer something very interesting with regards to analog and machine learning. So always looking for the right people and, a mix of people, obviously.
Yeah, for sure. It is one of the things that as I've been interviewing more and more people, it's, there's sort of the, I guess the logical, like left brain thinking, but there also are people that are looking for more creative, how can we bring people that are maybe have more of an artistic creative background into this field? Because they can provide just as much value in some ways as the programmers, because they're the ones who are kind of, thinking about the creative solutions and where this technology can be applied in everyday life.
And you're absolutely right. I mean, to add to that, we talked a lot about analog, and it is scary for some, right? We make that easy. That's part of what we want to do, and we are doing is releasing out to the world, right? The tool chain and SDK that you don't have to be an expert, but you can get all the value that we talked about from analog. And so you're absolutely right. We want creative people to think about what's the craziest idea you can think of that you want as an edge product, right? That's always on. I mean, people come up with the darndest ideas, and we want to allow them to be able to implement those, right? We don't want to have to think about it, but we want to make it easy for them to do it.
Yeah, and I think that's going to be a huge differentiator, I think, in the future. A lot of these like low code, no code, drag and drop type things where at least, you might have to get down under the hood to finally tune a lot of things. But a lot of it is just kind of just trying things out. And the more iterations, the more reps you can do, the stronger the muscles will be. And I feel like the companies are going to win are the ones that are going to make it just really kind of brain dead easy for people to start exploring and trying things out. Kudos to you guys for having that same type of mindset. Well, as I was thinking about people coming out of school, entering the field, hiring, all that type of stuff. If I was coming out of class, coming out of university today or whatever, like how would you suggest people get into this field?
I think people come out of school today with plenty of opportunities if they study electrical engineering, computer science, machine learning. We always strive to point out that, we're very different, right? And we want to bridge the gap between, one end of the spectrum, analog circuitry, and, this notion of machine learning, which is typically thought of as digital. And so, I mean, people coming out of school, please, look around. There are tremendous opportunities. And I would also encourage people to, not get too siloed into everything that they learned, right? And trying to go to a job that fits that perfectly, right? Because the one thing I can guarantee is technology changes. The things that I studied in university a long, long time ago, the basics are there, the core intellect is there, but the application space is just going crazy, right? And so you got to have a really an open eye. And I encourage, as I do my children, I encourage anybody coming out of university to really kind of, try to do something different, right? Especially as you're young. I mean, there's tremendous opportunity for STEM type, technology type people. So you have the opportunity to try many different things before you settle on some expertise that you want to gain.
Yeah, for sure. For sure. That's wise words. How do people connect with you, Tom? Are you kind of a LinkedIn person, Twitter? If somebody wants to find you?
LinkedIn is probably the best. I'm kind of old school, so I can't keep up with everybody else. But no, email, LinkedIn. I think most people, my address is out there, and you can reach out to our website. They know how to get me those emails to come in. But yeah, LinkedIn's a great one, right? I think LinkedIn's a very powerful tool, more geared towards corporate interactions, if you will, and connections. I really enjoy that quite a bit.
Yeah, that's good. That's good. Yeah. So like I say, I'll be sure to have links and all that sort of stuff to your website and off to your LinkedIn profile as well. There, as we sort of are getting near the end here, are there any other like topics or projects, things that I maybe didn't highlight or bring up that you would want to talk about?
One of the bigger things that we tend to focus on in a broader level is, what's happening in the world from a sustainability standpoint. I mean, it's a huge problem. I think it's hidden quite a bit especially for people like us in the technology fields, right? So, as I mentioned, I mean, when I look at the way that we do edge computing, I definitely see inefficiencies. I think people are so used to, constantly digitizing information, which costs power, and then looking at it before they know what kind of data. It's, inherently it's an inefficient process. And I think we've been hidden from that because of great advancements in our technology, right? Moore's law being one. We really have to think about, stop thinking about, hey, I'm going to charge my phone every night, so therefore I don't have a power problem. I don't have a sustainability problem. I'm going to plug in my electric vehicle. I don't have a sustainability problem. We actually do. When we think about how much energy we waste, like I mentioned earlier, when I get notified that a change happened in my house in California because a leaf blew, the amount of resources that got used for that false alarm, all the way to the cloud, should bother everybody. And we're really, in the bigger scheme of things as a company, we're really focused on that, right? So if we can use as low energy as possible to notify somebody when there's something of interest, that's a win. And I think it's a big win. You multiply that across billions of units that are going to be, always on sensing here in the next couple of decades. It's a huge challenge, and something that I think our industry really needs to focus on.
I love it. No, I 100% agree with that. I think we as an industry have had this mindset of sort of collect and send all the data all the time. And I think it's probably come out of this idea of cloud, right? There's sort of infinite cloud storage capabilities. The data center will handle it. And I think you're right. That's sort of proliferated, I guess, down to hardware, and it needs to stop. It needs the thought is it's not sustainable. So to kind of reuse the word that you were saying, it's not sustainable. And people, because you're going to be having to replace batteries pretty much, every day. And some of these things are going to be in remote locations that you just don't get to them for years. I'm with you. I'm thinking about the next generation. I'm thinking about my kids, the energy usage that is already going on today. Yeah, it's sort of it needs to be reined in. So I love that is a core component of what you guys are trying to do as a company. I applaud you for that.
It is. And you mentioned it. I mean, big data is a little bit bothersome to me, right? So some people speak of it as it's a great thing. We're able to get a lot of data to the cloud. We've over the last 5 to 10 years, we know that's inefficient. You don't want to do that, right? There's not big enough pipes. You're using energy you don't need to. But even in the ecosystem of the edge, there's a lot of efficiency to be gained. And we're focused on that, right? Moving data, digitizing data is the same as just wasting energy, right? And so, yeah, I appreciate the fact that you're on that same page, and we should have another one to talk specifically about that. I would love to do that.
Sweet. Very, very good. Very good. Well, on that note, Tom, yeah, I appreciate you taking the time being on the Conversations on Applied AI podcast today and all the work that you and the team are doing. We definitely will set something up in the future. I love to talk with people and then sort of come back in the next sort of, 6 to 12 months or so and see what's changed. So you've been doing this for a long time, sort of a veteran in the industry, and very much appreciate your input today and your perspective on where things are headed. And good luck with the future of Aspinity and all the work you guys are doing around analog ML.
Thank you very much. Great to be here.
You've listened to another episode of the Conversations on Applied AI podcast. We hope you are eager to learn more about applying artificial intelligence and deep learning within your organization. You can visit us at AppliedAI.mn to keep up to date on our events and connect with our amazing community. Please don't hesitate to reach out to Justin at AppliedAI.mn if you are interested in participating in a future episode. Thank you for listening.